Hello again, everyone. Today is a fun and festive day. It's Straw Hat Day. But sadly, I do not have one. How about you, Sam? You have a straw hat?
Not even close.
Dang. Well, hey, at least I'm not the only one. But today, instead of straw hats, we are going to discuss a new framework to make the right enclosure choices in today's high stakes environment. Now, what does that mean? Well, we're going to cover the latest insights on moisture risk management in modern high performance enclosures. We're going to talk about the critical role of continuous insulation in reducing condensation risks, a new decision making framework for choosing the right wall system, and we'll look at how disaster resilience and workforce shortages are redefining enclosure strategies. Here to lead us through all of those, Here to lead us through all those topics is Sam Raskin, the father of Energy Star. Remember Energy Star? And the Zero
Yes.
Energy Ready Home program. Remember the Zero Energy Ready Home program? Sam is also the creator and teacher of the Housing 2.0 content, which is based largely on Sam's latest book, Housing 2.0, A Disruption Survival Guide. The full program was established to help empower you, our building professionals, to design and construct higher performance, healthier, more sustainable homes at a fraction of the cost. Sam's going to lead today's seminar and also address your questions at the end. Now, before we get started, we need to recognize our main sponsor. Panasonic Healthy Indoor Living Solutions is helping builders across the country differentiate themselves with powerful, code compliant, and cost effective indoor air quality solutions that provide a safer environment for home buyers. Now, during the course of today's presentation, you can submit questions for Sam. Simply use the Q&A function located in the menu bar at the bottom of the Zoom window. I'll review those questions and pose them to Sam after his presentation. Now, sans straw hat, here's Sam Rashkin.
Hey, thank you, Mike, and welcome everyone. This is Rethinking the Perfect Wall. Many of you may be familiar with the perfect wall concept. We'll reintroduce you to it and talk about how we take it to the next level. So welcome to Housing 2.0. And what we're going to do today is wrap up the Rethinking seminar series for 2025. We already did Rethinking How to Scale Climate Solutions in January. In April, we did Rethinking How to Scale Systems Built Homes. And today we're rethinking the perfect wall. Also look out as we announce workshops for the Housing 2.0 fundamentals as we set up about 4 of those around the country this year. Now we're moving also after this seminar into our Managing Uncertainty series for this year. And we have a number of really important topics lined up. In June 26th, we'll talk about managing high performance certification uncertainty with all the news about Energy Star, how we prepare for disruption to certification programs. And then on August 21st, managing affordability uncertainty, I want to go over 6 pillars for substantial cost savings. I'll give you a little bit of a kind of a coming attraction later in the slideshow. September 11th, we'll talk about managing workforce uncertainty, future proofing, again, looking towards systems built solutions that are out there. And October 2nd, we'll talk about managing home buyer uncertainty and what are the 6 science-based strategies to sell hidden value. And finally, on November 13th, we'll do managing design trend uncertainty. Henry Ford said, if I listen to my customers, I build a faster horse. And effectively, this is about looking beyond trends and designing for the future based on how we can take the housing user experience to the next level. So how really to look beyond design trends. So again, look at also for the Housing 2.0 fundamentals. This seminar today, Rethinking the Perfect Wall, has 5 different sections. I always start with a Housing 2.0 background, just a quick overview of our whole program we do here. Then I jump into the perfect wall and how it was developed to optimize moisture and thermal control. Then why moisture thermal control is not enough anymore, which introduces us to the more perfect wall. And I'll wrap up with the more perfect wall, better business case studies, really amazing examples how we can apply the more perfect wall concept. So this is a kind of a little provocative, saying all the great guidance Joe Lstiburek has provided us needs time to be reevaluated. So background in Housing 2.0, as you've heard me say before, if you're a past attendee of Housing 2.0, the amazing data point that everyone should be really focused on if they're in the housing industry is that people spend nearly 70% of their time every day in their homes. Based on National Lab research, all the places we could be during the day, almost 70% in our home. So home is where life happens. And thus it's kind of, housing is the ultimate consumer product. It's where we spend our lives. And if you look at post-COVID, probably the amount of time we spent has been bumped up, probably to close to 75% if I had to guess. That's not based on data. And so with that, we look at why does Housing 2.0 exist? Why do we do what we do? And it's about homes where life happens better. And what we do is we provide a framework, fundamentals for how you can be consistent, providing a better user experience at lower cost. And most of my audience, based on all my background, are high performance housing professionals. And you're focused on the performance user experience. And what I'm here to say is it's a must have. It's where I spent my life and dedicated so much time, but I'm also here to say it's not enough. There are other critical experiences that drive why people buy homes and affect 70% of the lives that they spend in those homes. The design experience, the community experience, the quality experience and sales experience, but predominantly service, are all critical, as or more critical than performance. And so they hold up the housing user experience stool, and there are about 160 best practices baked into the fundamentals that we cover. So how do we get there? What's the secret sauce? How do we do better for lower cost? It all begins by realizing we need to rethink our business models. And we want to go from a first cost business model to a Housing 2.0 user experience based business model. So in a first cost, we spend as little as we can on experts and special features. In the user experience model, we invest in sure thing experiences that are absolutely guaranteed to make living in the house better and the experts it takes to get there. So we're spending more upfront, but the secret sauce is how we save cost. And the 6 pillars I'll talk more about in detail in the presentation coming up later in the series is we go from excessive waste to optimizing lean, from excessive complexity to optimizing simple, from excessive approach to systems as an afterthought to optimizing systems integration, from excessive quality assurance expenses that we just absorb to optimizing quality, from excessive customization to optimizing choice. We can get the perception of customization without nearly as much as we provide, and without excessive cycle time and process by optimizing productivity. And we'll cover these in more detail, but the net is this cost difference, savings, plus all the added value from the better experience, enhanced wellness, and lower ownership cost. And the combination of all that is about 30 to 50% cost advantage. So this is kind of what we do with Housing 2.0, either with seminars, directly with builders, and other training we do. And the empirical results I love that back it up are always impressive with the builders we work with directly, or I remember watching this presentation and just being amazed at how good a job Walsh Construction did just with design optimization, one of the 5 experiences. That's the only one they focused on in 124th and Nash in Portland, Oregon, a project they were going to do where they're building a second building to a project that was started a while ago. And the second building, compared to the first building, actual costs are 24% lower by optimizing the design. And the resource for all this is Housing 2.0, a Disruption Survival Guide. This has really been a massive amount of research that I've been curating and then vetting for over 5 years with hundreds of housing executives. It's got tremendous amount of content and graphics, and it's based on over 360 citations. And I have my favorite guest expert friends contributing essays. So it's really a great reference for how all this plays out. And that's the background on Housing 2.0. So let's jump into the perfect wall. And it's really focused about optimizing moisture and thermal control. And the basis for all this is how everything has changed when we went to high performance enclosures. In a low performance enclosure, we had a lot of thermal flow going through the assembly, a lot of airflow going through, and with high performance, tremendously reduced thermal and airflow. And the consequence of that was we created colder surfaces inside the assembly on the cold side. In cold climates, that would be the sheathing on the outboard side facing the exterior. In hot climates, it would be a drywall on the inside. So we have these colder surfaces, and we have reduced flows. And what's that all mean? Well, it means we have a lot more moisture risk because we have more wetting potential. If the surfaces are colder on the cold side inside the cavity, more propensity for condensation. And there's less drying potential because there's less thermal flow going through to dry out any wetness that may occur. So this is kind of a double whammy, and it's a critical risk that has to be managed. And the solution is basically you need bulletproof bulk moisture control, and you have to control vapor flow. So this is what drove a lot of the concept of the perfect wall. And the other one is just how much thermal bridging risk there was in traditional framed enclosures. The predominant ones are conventional framing and advanced framing, which are about 20 to 30% framing factors. That means about 1/5 to 30% of the wall is wood, with 1/3 or so the R value of the cavity with the insulation. And there are some more advanced wall assemblies with framing that are used a very, very small percentage of homes, staggered studs and double wall framing. And even they, I will suggest, are excessive thermal bridging. I think anything 10% or higher thermal bridging, we can do better and should be doing better. So this is a problem that needs to be solved, is moisture risk and thermal bridging risk. And so it leads to these building science risk and risk management imperatives that Joe Lstiburek addressed: bulk moisture control, airflow control, thermal bridging control, and vapor flow control. And so the risk solution was we could do a couple things. We could do advanced framing with continuous insulation, or SIPs, structural insulated panels with no studs, would be examples how we manage all this. But Joe's focus is predominantly on the continuous insulation assembly. This is his basic perfect wall innovation that was so important and so critical to adding clarity to what we needed to do as a housing industry. We needed a wall that managed our moisture risk, our thermal bridging risk. And so this is his basic diagram. He would go around the country teaching, and it reduced condensation by having outboard insulation outside the structure that, through its thermal control, would reduce the surface temperature in the cavity and therefore reduce the condensation risk. And secondly, you had the continuous insulation covering almost all the framing. So you have no or hardly any thermal bridging with continuous insulation. And then lastly, of course, you have the bulk moisture control layer, which has to be bulletproof and rigorous, comprehensive. So this is the basic perfect wall, and you can flip it for the roof and underneath for the floor, but it always works the same way. And so this is where all around the country Joe was appearing and teaching this. And again, what's important to me is what's interesting is so much attention to how we fix framing, and very little was addressed to SIPs, structural insulated panels, which offer a plug and play risk management strategy with a fraction of the challenges managing airflow, thermal bridging, and moisture vapor flow. So we'll come more back to this later as we get to the perfect wall, but this is where we wound up. And it leads me to the next module: why moisture thermal control is not enough. And so it's great that we have the building science risks, bulk moisture, airflow, thermal bridging, vapor flow, all those addressed with the perfect wall that Joe introduced. But I'm going to submit we have other imperatives. And what I want to talk about next is disaster: flood, impact with flying debris and hurricanes and windstorms hitting the home, earthquake resistance, wildfire resistance, pest resistance. Pests on most people's list are not a disaster risk. Take a state like Florida, where they have $1 billion of termite damage a year. That's $1 billion termite event every year equivalent. And that's your metric normally for high impact disaster events, or $1 billion events. And every year Florida has $1 billion termite event. So I think it should be included as a disaster risk. So with that in mind, we look around and we go, holy cow, if we don't considered disaster risk. It's just getting incredibly worse and worse. We're accelerating the frequency of disasters, the magnitude of the disasters, and the expense in terms of the number of billion-dollar events. And it's all kind of by science being connected and linked to the record temperatures in the land and the ocean. And it's just driving through physics a lot of more moisture evaporation, a lot greater temperature gradients that create these just disaster events on steroids. So disaster risk is growing exponentially. We all know that. And the other factor about this is that there's nowhere to hide. Virtually, if you look at disaster maps from FEMA and others about where in the country you're exposed to droughts and winter storms and cyclones and tornadoes and wildfires and flooding and severe storms, like I said, there's almost nowhere to hide. Virtually the entire country. And more importantly, if you look at the risk exposure, it's been calculated about $6 trillion of estimated market value for 43% of the homes located in high disaster risk parts of the country. And why you should care is that the insurance companies aren't even near ready to manage this much exposure. Thus, we have the availability of insurance is decreasing exponentially and pulling out of markets as fast as you can turn around every day. You see other stories. And it's because of just the rapidly growing exposure, the stark increases in cost of construction to replace what's been damaged, and then the increases that are coming down from the reinsurance market. So just even the availability of insurance is hard, and that gets reflected in the cost. On average, over a 40% increase in homeowners insurance. In some parts of the country, it's doubling or tripling for some homeowners. Just the insane cost of insurance is making it a greater expense than the energy for many, many homeowners, if not most. And the other part about disaster risk is that it's manageable. Here's a lone building standing after the Oakland Hills fire. This was a big event when I was in California. The more recent fires have lone building standing examples as well in LA. But in this one, you look and you see the basic best practices work. You have unvented, non-combustible roof materials. You have unvented attics. You have non-combustible decks and materials and walls. And the basics are really effective. And so it's really important to manage. And the same thing with hurricane risk. This is the lone building standing after Hurricane Harvey, Mexico Beach. And again, the basic best practices work. A hip roof deflects wind better than a gable roof. And especially an unvented attic. In this case, the attic had closed cell foam sprayed up against the roof sheathing and just strengthened the roof as well as provided insulation. You have impact resistant insulated concrete forms, which are concrete poured in the middle of the insulated blocks. And then you had these concrete pilings, which were used to raise the whole building a whole story above the floods and the storm surges that would happen. And a real very rigorous continuous load path of all the loads from the roof to the walls to the foundation. Everything was being connected and managed. It just works. And when you see all the devastation around this building, it's amazing how effective it is. Of course, the building behind, you notice the same hip roof and things going on. So again, we know how to manage the risk. So disaster risk is really important, but there's a third risk that we have to address, and that's workforce. The availability, skills, and productivity of the workforce are all under stress. First of all, it's just the age of the workforce. So the Bureau of Labor Statistics reveals that the average construction worker age is over 42. And another study done by the Home Builders Institute tells us for every 5 aging workforce workers retiring out of construction, there are only 2 in the pipeline to replace them. It's just a tsunami of just damage ahead when we just don't have enough workers. And we already see this also reflected in the reduced skills. 62% of construction firms report candidates lack the essential skills needed to work in the industry. And why that's so important is that causes delays, which then drives up costs. At the same time, we're in an absolute affordability crisis mode. We're beyond crisis to whatever comes next. It's just everything's working against us. So the workforce is so critical. And one study, again from the Home Builders Institute, quantified it at about 700,000 plus new workers needed each year to meet the 1.5 million home shortage that we have. That number will keep oscillating from 700 to 650,000, but the number of workers is just so far beyond what we're replacing and putting into the industry. And the other part of workforce, as I mentioned, productivity is just not there. Here's what impressive productivity growth looks like. This is the auto industry. You start making cars in a back room in 1903, you go to the assembly line in 1913, and by 2020, it's just all this robotics and advanced manufacturing. Now compare that to housing and how we build the enclosure, and you go from impressive productivity growth to glacial. Here's a home under construction 150 years ago in 1877 in Omaha, Nebraska, courtesy of the Smithsonian Archives. And then you can look at a home being built today and go, where's the innovation? Where's the productivity? You see the same products strewn across the job site, the same excessive wood framing, and you see the workers in precarious working conditions in terms of just hovering over there, probably without enough safety for their construction. You see, we're just building with hardly maybe 4 innovations. We went from balloon framing to Western platform. We went from dimensional lumber to engineered lumbers and better tools. And it's just stunning the lack of what's happened in 150 years. The result is, if you measure the productivity, there's a 50% decline since 1968 in building productivity, while every other industry has become more productive. And you see this in the growing cycle time that's being measured. One of the last measurements, cycle time had increased to 8.6 months on average to build a new home. Production builders might be closer to 4 months or 3 months, but this is an insane amount of time to build a house, and it adds so much extra cost. And it's up from 8.3 months in 2022 to 2023. And why, again, I keep saying cost is there's a cost to be in business, to operate a business. IBICUS, a research organization, did studies years and years ago, quantified it at $500 to $800 a day. I assume it'd be higher today. Many builders will argue that their costs are lower. I would submit many builders don't really know their costs or do real detailed calculations, know all the interest carrying charges, office expenses, leases on trucks, everything that goes into operating a business. So if you have stick framing is for production builders 95 days. Remember, it's 8.6 months for the industry average to construct a home. But let's say it's 95 days for a production builder. Offsite is 65 days, and that's quickly almost $25,000 of savings just from time on operations cost. So again, that's carrying cost, efficiency, interest cost mitigation. But that's only the first tier of cost savings. Then you have velocity. If I'm building more homes per month, and every home, my margin's 20,000 per home, and I build 1, 2, 3, 4, 5 homes a month, that's 20, 40, 60, $100,000 of extra revenue per month. Velocity is huge, and then risk. There's so many changes and forces acting on market, on inflation, economic uncertainty. The longer you build, the more risk you absorb. Risk is money. So you have these 3 cost factors, and time is huge for the industry. And again, here's a McKinsey & Company kind of mapping out of the productivity difference between manufacturing and construction. With high-tech industries, it's about a 3x difference, but manufacturing has 1.7x more gains than construction. And construction, I mentioned again, is the only industry that has decreasing productivity. When McKinsey & Company put pen to paper and rigorous analysis to come up with how much is that costing the industry. Remember, we covered all the costs of time. It's about $200 billion labor productivity gap suffered by the construction industry. And they feel a lot of it could be closed by adopting advanced manufacturing methods. And So I get back to all these workforce issues, disaster issues on top of the building science risks. And I say maybe it's time to rethink the perfect wall and add these other risks. Disaster, flood impact, wildfire pests, workforce availability, skill cost. Those have to eventually be factored into the decision process to inform the best choice you can make. When I look at all these details we have for these high performance walls, and I look at the shrinking quality and availability of workforce. This is tough to build. These are complicated assemblies. And this is in a outdoor environment setting with all sorts of other constraints. This is not so perfect. So let's talk about a more perfect wall and how we get there. And this is where I put together a little tool, and I'm going to ask everyone forgiveness. This is me trying to use my best experience I have to put in some straw man assessments here of what's the risk for different assemblies. So at a glance, you can start making decisions. All this could be much better. We can get 20, 30 really good experts around the virtual table or real table and hammer these out in a better way. But what's important is not the precise results that you see on this tool, but that we need some way to really gauge the risk, measure the risk, and factor it into the decisions. So here, the first thing is the building science risks. And for site-built walls, my main options I can build on site: frame wall with continuous insulation, concrete block in southern Florida and some markets still built with concrete block, and something called an insulated concrete form, which is the inverse of a concrete block, where the concrete's in the middle of the insulation on the outside, which looks much like a concrete block, but it's assembled in the field, so it's site-built. So with frame walls, you have all this high risk. Now, again, the key is high is red, medium risk is yellow, caution, low risk, green, goes low. So green's low. But you see all red for frame walls for thermal bridging, condensation in these assemblies, and bulk moisture. You have to manage all those risks. Now, with continuous insulation, thermal bridging goes good. Condensation's less of a risk, but it's more than concrete blocks, so it's kind of yellow. And bulk moisture is still the same risk as it is with any assembly. You have to be really great at managing bulk moisture. Now, concrete block has really bad thermal bridging, but really because of it can withstand moisture in all its forms, and it's such a hygrothermic battery for absorbing moisture. It's great for condensation and bulk moisture. And insulated concrete forms are pretty much the same, plus they have thermal bridging. So you have these choices, and you see how I kind of work it. Now, for systems built, I can build a frame wall in a factory. So just build it indoors and has the exact same profile for thermal bridging, condensation risk, and bulk moisture. And a frame wall with continuous insulation could be built in a factory, I think, but you'd have to use something like extended plate and beam, which is a detail I won't go into right now. But that would, again, the same profile as you would for building it on site. It just, the factory doesn't change that. But we have structural insulated panels you mentioned earlier, which has really outstanding thermal bridging, amazing lowest condensation risk because there's no vapor flow through that sandwich panel. And it has the same moisture risk because it's a skin, wood skin. You have to manage the moisture, so it's red. And then you have all these concrete precast or manufactured concrete systems, precast insulated concrete wall panels, insulated concrete panels, which are kind of like an insulated concrete form, but a panel versus a block. So it's more site built, more systems built. An insulated concrete core wall panel, I'll show you an example later, but it's a concrete sandwich around the insulation. So those walls are amazing at bridging, condensation, bulk moisture. It's amazing how powerful they are at managing building science risk. Then comes disaster risk. Now, frame wall, again, is not good for most disasters. Flood, impact, not very good. Good for earthquake, wildfire, and pest resistance, not so good. And the same frame wall with continuous insulation. Concrete block is great for flood and impact, not so good for earthquake, and really good for wildfire and pest. And insulated concrete forms are almost the same, except they're not quite as good. They're a little better than concrete block for earthquake, and they're better for wildfire resistance and pest resistance. So you kind of see how this works out. For systems built, again, those frame walls and frame walls with continuous insulation stay the same. But structural insulated panels are not great for flood, much better than frame walls for impact, but not as good as concrete. They're good for earthquake. They're really good for wildfire because of unvented attics, and they're better for pest resistance, especially with borate treated skins. So, a little better. And then the concrete assemblies, precast concrete walls, insulated concrete panels, and the core wall with insulated concrete are really great. Earthquakes, they need a little more attention. So you kind of see how that works out. And then for workforce risks, all the site-built ones require a lot of labor and attention. On skill, concrete block and insulated concrete form are pretty simple and have a lot more inherent plug-and-play benefits in terms of air leakage control and insulation quality. So the skill requirements are actually pretty good for them. When we go to systems-built walls, all of them have better workforce benefits because they're built in a plant, so availability, skill, productivity. There are a little bit of skill issues with frame walls and frame walls with continuous insulation require more details in the field that have to be managed and integrated than you do with the other panels. So there you have my assessment. And maybe I'm wrong in some of these, so we can change that. But when you look at the whole package, you look at this, you have basically at a glance an ability to see where the risks lie with which wall assemblies, and we can work this out and kind of figure out how to optimize this. But I call your attention to the big chunk of systems built options that have incredibly good risk profiles. And let's look at case studies where, because they're so good at managing risk, I think they've yielded some really good outcomes. So the first company I'm going to talk about said, you know what, insulated concrete core wall, we're going to innovate this system, bring it to market completely automated, and really be disruptive. And the name of that company is Onyx. They're based in Florida. Now they're looking to build a plant in Texas. They think the world demands building different and better. And the challenge they had building Florida, remember the termite capital of the world, the hurricane capital of the country, all sorts of impact resistance and flooding resistance. You have everything coming at you. So they had to select the perfect wall for Florida. And when you look at basically wood versus concrete, risk by risk, it's pretty stunning to see just how compelling the resilience risk management advantage is for concrete. Because sometimes we aren't even thinking about all the risks we absorb with wood: mold, rot, dimensional stability, warping, expansion, contraction. All of that goes away with concrete. On disaster side, impact resistance, pest resistance, non-combustibility, all that goes away with concrete and is a heavy risk with wood. And then in workforce, minimum job site waste, minimize labor, and not having to have all this management to protect the job site as you do with wood, all that goes away with systems built concrete versus wood. So they just rethought the perfect wall. They said, we're building in Florida, we're going to build an assembly that's bulletproof. And so first thing you should notice is back to time. It takes 22 contractors in 8 months to build the average home. That's the US Census Bureau data for an average home. Again, let's assume for a production builder, it's 3 to 4 months. But that is an incredible contrast to what it is for them. One system, 30 days, out of plan, and then they're done. And that's with maybe a few people come in the field to do some painting and minor work. It's incredible how lean it is and how short it is. So I did some back of the envelope calculations. What does that reduce cycle time and increased velocity, more sales add up? They did about almost 500 homes last year in Florida. And let's say they reduce cycle time from 30 to 90 days to compare them to a traditional production builder. We'll use 15% as an average margin, and the average sales price for homes we're going up down there competing with might be $600,000. The cycle time savings and velocity benefits ended up $45 million, or $90,000 per home for each of the 500 homes. So in other words, the choice to say we're going to innovate the enclosure, save them $90,000 per house. Now it's a huge investment, and they're a vertically integrated company. They buy the land, they develop, they have the factory, they make the homes, they assemble the homes on the field. They're the whole shooting match, which is, if you see me do speak about offsite, this is why it fails, is because when you have to sell to a builder, that's when it's incredibly difficult. And so this is their plant. This is a completely automated robotic system. All the, the CAD drawings go in, and all the forms are set automatically by the machine. So concrete can be poured automatically, creating these 2-inch panels. They then get steam cured to about 8 to 10,000 PSI. They are bulletproof for moisture flow, vapor flow. Just can't go through these. This is waterproof assembly. And then they are sandwiched together in 2 panels. You can see there are hardly any people working on the line here, but when you got down here, there's some people working, putting insulation on top of one panel that can be sandwiched to the other panel, as well as some of the wiring and plumbing that might be in the wall. And then you create these wall assemblies ready to go to the field in sequence stage for how they will be assembled piece by piece by piece, numbered and ready to go. They make the bathrooms in pods. This is the pod inside the bathroom. It looks something like this. And then the roofs are made with steel. They have a forming machine that takes the steel, bends it into channels, and then they make the steel trusses in the same plant they're doing the concrete in the middle of the factory. And what's amazing, they also make the stem walls and the stairs, the outdoor stairs, the indoor stairs, everything, all that is made with the concrete in the plants. So this is field assembled foundation, and notice how high there is above flood elevation for maximum resilience. And look at what this looks like when all the panels are assembled. When I say bulletproof, this is total protection. I mean, this is a safe home. You've heard of safe room. This is a safe home. And the bathroom itself has a concrete lid, so that's a safe room in a safe home. And the stairs you see there are made in the plant, the foundation. There's just no airflow going through here. There's no thermal flow beyond what can get through the insulation and the sandwich. No vapor flow. It's just totally risk managed. These are the stairs that are made, and they put in these really nice tiles in on site. So that's one of the things that's installed on site. You see how the panels are clipped together with the angles that are set in the panels so they can assemble in the field. This is what it looks like assembled. The streets look like this. So it looks like a traditional neighborhood. Here's from the literature. This is starting at 500,000. This might be about 6 or 8 months old. Starting from 300,000. Some of the prices are up to 600,000 and higher. But it looks like a regular home inside. You just don't even not aware it's a concrete home. It is, again, total protection, no termite risk, which also means I'm not throwing all this termiticide in the soil all around the homes all year long in these neighborhoods, as you do with all the other neighborhoods in Florida. So all that termiticide is not going into the ground in their developments. And this is a total package. If I call a home and curate, what is the user experience for this product? First of all, on affordability, the cycle time is reducing costs. And because it's a bulletproof house, they've negotiated insurance premiums that dwarf the energy savings you get from like a zero energy ready home. The insurance benefit for the homeowner might be a 2x or 3x better savings than the energy savings. That's how important resilience is in Florida. The sales process is mass customization. They've got all that excessive choice other builders do. They take out of the equation. It's very simple, limited choices, but you have ultra low bills, ultra low maintenance, and wellness. All this resilience protection, moisture, hurricane, flood, termite, a safe room, enhanced indoor air quality with all the hard surfaces. And in the future, you have all this advanced quality. The home will be like so much more resilient and visually will demonstrate such superior ability to withstand everything that nature has to throw at it. So the durability, and my quick calculations, this is over $100,000 of cost savings and added value. So this is where you look at how compelling it could be if when you take your process of what's my best perfect wall assembly, my best enclosure, and you look at it in a really comprehensive way, what is the total equation of everything I'm getting? This is impressive. And then they're selling homes with insurance. Your competitors are going to have to fight and figure out what they're going to do with insurance. Just that alone optimizes probably their ability to attract buyers. One more example case study is here's our risk management tool for the More Perfect Wall. And I always, you know me, I'm a big SIP fan. I always talk about SIPs on my seminars. Comes up quite a bit. And I just feel it's an underutilized innovation, partly because it goes to market in a way that I think its price is higher than it needs to be. But it has an amazing risk management profile, as you can see in the tool. So I can try to build all these layers and do all this to get to Joe's perfect wall. And then when you look at what it really entails, take that concept sketch to an actual construction and then all the moving parts you have to manage. I go, this is a tough business. And I'm not even managing disaster and workforce. So in contrast, when I look at SIPs and how elegantly simple it is, it manages the building science risks and the disaster and workforce. And let me give you some examples. So here are all the air barrier details I have to worry about with traditional framing. This is the thermal bypass checklist kind of summarized for you from the Energy Star Certified Home Program. I know this because when I put it together for version 2, I organized it this way just so it could be aligned with how we build homes. And look what goes away when we shift to SIPs. It's just stunning. You're building a complete air barrier assembly. The attics, the walls, floors, when you use them for floors, it's just a perfect assembly. It's like a Yeti cooler. And the only possible air barrier detail left would be if you had a whole house fan in a house without a SIP attic, which I don't recommend. So virtually everything goes away. You know, all the air barriers and all the details I will walk you through. For simplicity, many of you see my presentations. I can cover these, but what I want you to understand, this is a lot of risk reduction. And then we look at all the air sealing details we have to manage. Again, these just come from all the basic auditing of everything that has to be done when you do a framed home. And it's about a half-mile cracks around windows and doors and sill plates, and it's all these penetrations and geometry. And when I go to SIPs, the biggest chunk of that goes away. There's still some penetrations that have to be managed. You still have sill plates you have to seal, but it's just easier with SIPs because of all the big size panels and much smaller number of joints between the panels than you have in traditional framing. So huge benefits. And then you get to have a thinner wall. This is Oak Ridge National Lab. Ran some analysis and I looked at a SIPs 4-inch wall compared to a 6-inch frame wall, one with quality installation and one with typical installation. So 4-inch SIP wall would be R14, and then a typical installation for a 2x6 would be R11. And if you had the extra resources and cost to impose higher quality, you can get it almost close to what a SIP 4-inch wall is, but still less. And when you look at all the savings managing grade 1 insulation, all the less work you put into air sealing and barriers and rework and reduce waste, you have less dumpsters, less time, you have 30 more square feet because 2 inches around the entire perimeter on a 1,500 square foot house, right out to about 30 square feet. If it's worth $500 a square foot or $400 a square foot or $300 a square foot, you know, that's 10 to 15,000 right there. What's the value of all the resilience benefits and dimensionally accurate walls and stronger walls and higher quality construction? All this is serious numbers. If you're going to get to the right number, this is the kind of calculus you have to do. And then a big thing is when you look at a SIP attic, you have no topside air barrier. And so we put a ton of insulation up there, helping it doesn't compress. And people walk through it to run cable or wires. They don't upset it. And it just wasted space and it's vented. And with a SIP attic, it's 100% air barrier, top and bottom, no missing topside. If you put in ducts and heating, cooling equipment in the attic, now you're taking like a 40% hit on the efficiency of that equipment. So this is a SIP space that's for free that can be converted into spaces like this. So that's a lot of extra value. And then we mentioned all the resilience benefits. So I'm just going to wrap up with one quick case study. Ron Howard, from the very get-go, understands he's building a consumer product, the ultimate consumer product, a home. And he has a very target audience. He wants workforce housing. He builds in the mountains of North Carolina. And he didn't come up with a design, and then say, now let me go figure out as an afterthought all the systems like structure. From the very beginning, this home was designed with optimizing SIPs. Simple roof, simple footprint. He traded off the basement for the attic space he's getting, and he put the house on a slab at lower cost. He has the walls and everything are designed for the span of SIP roof panels. The floor plan allows for the post and beam locations, no exterior wall plumbing. He has 4-inch walls versus 6-inch walls, which add about another 20, 30 feet of space. And he's using the attic volume for storage and for vaulted ceilings. He's on 2-foot dimensions. Everything works. And then he invests all these savings into all this quality. You don't see what everyone else has up for siding in this market for new construction, which is cheap vinyl. He's using cementitious siding, and really quality colors and trim. He has the floor plan again on the left. You see the columns are designed to go on the wall, so you can put the ridge in the middle and run the roof and meet the span capabilities of the roof panels. On the bathroom, you can see all the plumbing that's not in the exterior walls, easy to do. He has basically very simple footprint. He has extra square footage, as I mentioned, because the walls are thinner, 2-foot dimensions. And here's the section for the house, and there's the storage above the bedrooms on the left side of this floor plan. Over here, the bedrooms. So that's all storage above there. And then he has vaulted ceilings in the rest of the house, the great room, the dining, and the kitchen. So he's got all the advantage of a more luxurious space because it's the SIP construction. And look how simple the roof plan is, how easy it is to build with SIPs. And so if you just got a framing bid, we ran detailed calculations through a cost calculator we developed for the SIPs industry. If you ran the numbers and said, okay, what would framing cost me and what would SIPs cost me? You get sticker shock maybe as a builder. Wow, the SIPs package is $14,000 higher than a framing package. But what about all the insulation I'm going to have to install? The air sealing I don't have to do. What about all the value of having a smaller mechanical system, the value of having less quality work, less dumpsters? What about all the extra space I have for storage? What about all the extra vaulted space, the extra floor plan space because of the thinner walls? When you run all those calculations, include all the benefits, SIPs was $400 lower cost, and it added $37,000 of value for resilience, for extra square footage, for extra quality. It's just incredible what happens and flips when you do a detailed full calculation. 37,000 plus cost advantage using SIPs. So it's a great case study of how a builder is delivering this amazing quality workforce housing for under $200,000. I don't know anyone's close to what he's doing in that market, or probably any market. And it's only made possible because he did this fully integrated approach to optimizing the enclosure. So final word, and I'm done. The more perfect wall. If you want to optimize business, you got to optimize the enclosure. It's absolutely critical part of your business. And if you want to optimize the enclosure, you got to optimize the design integration. You're building the ultimate consumer product. You can't have afterthoughts. What do I do about structure? What do I do about mechanical? What do I do about plumbing? All your entire set of systems, storage, everything that goes into your home has to be integrated in the design from the very first time you start crafting the floor plan on CAD or pencil to paper, however you do it. This is how you get to the more perfect wall. I hope this makes sense. This is me again signing off and handing back to Mike.
All right, thank you, Sam. We certainly have questions that have come in, and if other people have other questions, please feel free to submit those via the Q&A option down there near the bottom of the Zoom window. So, Sam, Mark wanted to know, he's in agreement with you that there's little risk of condensation in SIPs through vapor diffusion, but his comment is that air leakage can deposit a lot of condensation in SIP assemblies that aren't well air sealed. And once that condensation is in the assembly, how do you get it out?
Good question, Mark, it is, I think. And essentially, you get it out because SIPs are inherently airtight. I almost defy you to go around the country and find a SIP home that's over a 1.5 ACH 50. I'm probably, of all the homes I've seen, the SIP homes, without even going for certification programs, sometimes are just coming in at 1.1, 0.6, the passive house level. So there's hardly any airflow to worry about. But on top of that, SIPs are installed with belts and suspenders. So when a panel is joined together, the way it's usually set up is there are splines that go on either side inside the outer facing of each panel. And so the panels go together and they use foam to seal where the insulation in one panel meets the other panel. And then the splines are in there to kind of create the structural connection. And then they tape the joint so it's taped and it's foam sealed. And the same with the roof panels. And it's why they're so tight. The one risk factor you have with SIPs will be at the roof, where you have to be absolutely, like, again, bulletproof. You can't that's where all the moisture is basically collecting because of stack effect. So there's a basic detail for how we flash the ridge joint. Again, you put in the ridge, you put flashing over the top, or sometimes you use like a house wrap material to flash on top of it and tape it to the roof panels so you can have no way for the vapor flow to get through to the ridge, where that's when you can run into trouble. So the one risk factor you have to manage is the roof seam. Now, and if you saw my tool, I have read for bulk moisture and SIPs, because you got to be really militant about managing the airflow, just like you say. But you have so much less to manage than you do with conventional framed assemblies. I mean, it's so much less joints and less detail. So it's easier and it can be done. But you got to manage it, to your point. And so thank you for the comment.
Jacob wanted to know, is it cost prohibitive for production builders to switch to ICFs or some kind of version of an insulated concrete panel?
Great question. That's Jacob. And our kind of optimized way things would be, if the world was perfect, would be that the builder actually constructed the homes, but the builders don't construct the homes. Builders buy the land and then they outsource all the construction to the trades to build the homes. They don't own the equipment, they don't own the workforce. They have their own construction manager on site, of course, but it's just a bifurcation, unlike any other business. If Whirlpool makes appliances, they manufacture, make them, and sell them. And so they invest in equipment, they invest in technology and innovation to do those things. So if a builder has to use a SIP panel, the way the industry currently works, the SIPs has to convince them to buy a panel, and then they got to find a framer who will work with it, and then they got to find an electrician that knows what to do with it. So this is a friction that creates low market penetrations currently for the SIPs industry. Now, the way you fix it is you do what Onyx did. You say, I can build a better home 1/3 the time with a 3x better consumer experience in terms of durability, protection, future value, peace of mind, no worrying about having to have termite people come around. I don't have to worry about damage to the home. And it is so comfortable and it's so healthy and has hard surfaces that are easy to maintain. So I can do all that at lower cost if I own the production process. I make the product. I'm not bifurcated. I buy the land, I make the product, I set up the product on the site. And that is the secret where we'll see inroads in systems built housing, I believe, is when companies see this amazing opportunity to just take out so much risk by choosing assemblies like this. I mean, again, the benefit that Onyx gets just from taking out all the insurance risk in a market that's starving for low-cost insurance providers, if you can get the insurance, is like a massive advantage for them. And it just almost, it kind of guarantees them an amazing advantage against every other builder, that they don't have to worry about insurance. And so all I'm saying is we're not in Kansas anymore. all these new imperatives are acting on us as an industry. We all can choose how we adapt and when we adapt and what choices we make. And I'm not telling you to do what I recommend, or I'm not even making any recommendations, but I'm showing why certain groups chose certain ways to go and how a builder decided to integrate SIPs in every aspect of his product development and can do SIPs for under $200,000. And it's a stunning quality home for that buyer. The bigger home might be $300,000. Again, a massive cost advantage compared to any competing homes I've seen. So there are ways of doing this, either as a builder by saying, I'm going to manage my product from the outset to be integrating these advanced enclosure solutions that manage risk, or I can be a company that says, I'm going to just take the bull by the horns. I'm going to provide a better product and be the developer and the manufacturer and the builder and buy the land. And so these models, I think, are going to actually come about more and more because I think they're compelling.
So I want to stay on the topic of SIPs for just a moment, and then we'll bounce to a couple other topics. Sam, Michael wanted to know, other than performance, can SIPs be environmentally friendly?
Other than well, first of all, they use about 50% less wood than a frame house, so it's resource efficient just from that basis alone. They are incredibly, I think, durable and strong, and I think there's a good chance they'll last longer. So on that basis, they're environmentally friendly because they just don't go into landfill as quickly. And then again, they use so much, they're inherently plug and play, super airtight and super thermally bridged. So the expenses on SIP homes, I bet you, if you actually compare the modeled consumption to the actual consumption, the modeling overstates the energy use in SIPs homes. I bet you SIPs are just delivering tremendous environmental benefits that just aren't even being counted. The trouble we have is we have this business model with SIPs, again, where the manufacturers have too much friction just trying to sell panels to a builder versus having set up services and doing other things that make it easier. I believe solutions will come for SIPs. I believe these concrete systems are really exciting. I believe other builders will find ways to just be more productive with the usual systems and just using panelized conventional framing that they've figured out how to be pretty optimized. But I'm a low risk guy. When I see something as exciting as that much risk reduction available, I love building my business model around having so little risk. I can sleep at night like a baby, not worrying about all those issues. So,
Got a couple of detail-oriented question on SIPs, Sam. Craig wanted to know, how do you close the connections between the vertical wall and the SIP roof?
the vertical wall and the SIP roof. There's the most common way is the SIP wall has a sloped cut on the top so that the panel sits right on it flush. And again, you can belt suspenders, you can have foam between the two, and you can tape so they're airtight. So that's the most common way they do it as a detail. What I recommend people do is, who are interested, actually, if you're interested in SIPs, go to the SIPA website, Structural Insulated Panel Association, and they have amazing resources on SIP details and how panels connect and how they work. And better than me, it's an incredible resource for just all the answers to how this advanced technology assembles and is manufactured and how it works.
So Jeff had a question about foam shrinkage. Is foam shrinkage inside the SIP panels still an issue, or is there maybe a better way to manage it?
It's a much bigger issue on continuous insulation because you're just adhering the insulation to the outboard sheathing. And I understand maybe there's less shrinkage than there used to be, but I believe there's still shrinkage. In a SIP panel, there's this massive, like 5-ton press or whatever it is, and this incredibly strong adhesive bonding the insulation to the skins. So it can't shrink. It is all kind of it's just this massive glued assembly, and there's nowhere for the insulation to shrink. It's just so glued. So the issue is more to this continuous insulation that's not adhered to anything. It's just being nailed to the sheathing over the water resistant barrier. And I remember Joe Lstiburek showing his house when he put on those 4-inch insulation panels, continuous insulation on his roof and his walls. You had these huge black lines starting to appear on the roof and the walls because gaps in the continuous insulation. Now, again, I think I understand that they're figuring out how to reduce or eliminate the shrinkage, but I think shrinkage is still an issue for continuous insulation. But for SIPs, when it's bonded and with this super, super strong adhesive to the panel, there's no place for it to shrink. And as a result, there's no vapor flow possibilities in the assembly. It's just, there's no way for vapor to get in and move through it. It's just it's like a Yeti cooler. You're worried about vapor getting inside, all the ice melting, the vapor gets into the Yeti cooler walls. It doesn't happen. It's the beauty of a skin assembly.
So we've got more questions coming in, which is great. We love hearing from everybody. Let's have a question on magnesium oxide SIPs. Where is the consideration for something like that? And then there's a couple of follow-up questions.
Yeah, Magboard is a very interesting option for SIPs. There are a lot of different skins being considered besides OSB. You could do plywood, you could do composites, you could do drywall, and Magboard another option. It's magnesium oxide board. I think it's predominantly made in China, so that you have that supply chain issue to deal with. The biggest issue about Magboard is that it's constrained to 4x10 panels. So to me, that's the biggest issue. It's 10 foot is you can't make panels like jumbo panels that really make the assembly of SIPs elegant, because you have such big wall panels that make it really beautifully elegant in terms of again creating like a Yeti cooler. So that's the big challenge with Magboard, but it has amazing performance in terms of being like almost an inherent WRB, because it will shed the water. You almost don't need the house wrap on top of it. On the inside, you can also use it almost to as a replacement for the drywall. Almost can go just spackle the joints and go and just finish the Magboard on the inside. So the exciting part about Magboard is you eliminate the drywall layer on the inside and the WRB on the outside, and you keep extracting more and more cost savings, more and more layers that you don't have to build. Remember how a window is like a perfect assembly? There's almost no risk in the window. It's the way it's hermetically sealed, and then the assembly goes into the frame. The window itself is a bulk moisture control layer, the vapor control layer, the airflow control layer, and the thermal flow control layer. So the thermal flow is admittedly limited to whether it's 2 or 3 glazings and coating and so forth. But it's risk-free. It's like plug and play. I have all my building science packaged in one glass layer. So to the degree that you could do Magboard with SIPs, you're almost doing the same thing. You have your airflow, your thermal flow, your moisture flow, and bulk moisture flow with the effective WRB on the outside, plus the taping and the sealing that you have to do at joints. But again, it's from China. It's from China as the main supplier of Magboard. I think there's some local suppliers trying to get in as an option. I don't know. We have to check to see if that's available or not.
Yeah. So the follow-up questions then is, like you talked about the SIPs versus framing. You had that slide in there, Sam. What about Tim used the phrase cost risk comparisons, where the heavier concrete solutions require more expensive foundations?
Again, I look at the price point of onyx homes. I'm going, if the foundations have extra costs, it's not impacting the product to be any more expensive. In fact, it's less expensive than competitive housing being built with traditional framing. So I don't think that the foundations add any significant cost. I think by the time you look at all the wind loads and other things that with conventional framed homes in Florida and all the, they have to be able to hold the house down when the hurricanes come through. I don't know that the foundation costs change much. I think the biggest cost is that they build a concrete foundation stem wall to get the house up above flood elevation. So that's a cost they do because they want to be a resilient builder and protect the homeowners with having that surge or flood risk managed. Uh, so I don't think the foundation cost would be a factor at all. It must not be because we look at how the homes are priced.
Yeah, I'll back up on that one, Sam. When we designed an ICF home a little over a decade ago, which we did end up building, just full
Yes.
disclosure, but when we designed it, the ICF basement and the ICF above grade walls just stacked on top of each other. There was no additional
Yeah.
need of anything. In fact, we could have done a standard foundation wall that you would have put a wood frame wall on and done ICF on top of it. There was no ramification to the foundation walls whatsoever.
Well, it's a good
Yeah.
question. Intuitively, you think concrete's a lot heavier, so I understand the question. Yeah.
Yeah. Now the big question that comes in when we always talk about concrete, Sam, and we can just predict this is happening, is the environmental risk comparisons when all the embodied carbon within concrete. So a lot of people are interested in your thoughts on that aspect of talking about concrete walls, about the embodied carbon.
Yeah, as you watch the tens of thousands of homes going in from Paradise to landfill uh, or from Palisades and from all the cities in California from the damage in the wildfires in LA recently, and you look at the toxic stew that those homes represent as they're dumped into landfills, as they burn with all the electronics, the carpets, the appliances. There's so much nasty stuff. You couldn't even, it's almost like it's a Superfund site. And so all that stuff's going to landfills because it's being built with a non-resilient product and you're telling me to worry about the embodied energy. I don't. And the big reason I don't is because the low carbon concrete has some amazingly high potential solutions ready to come to market. I know research is being done and companies like Onyx and others are really making some inroads. And I believe we'll see the low carbon concrete really be arriving in the market in a reasonable amount of time. But also when I look at Europe and I see all the homes that stand there for 400 years, 500 years longer because they're made of stone and masonry and concrete. And I go, oh my goodness, I'm worried about embodied energy. And we're hoping our homes last 50 years or 100 years the way we build here currently. And we could build homes that will last for hundreds of years. And you want me to get really worried about the embodied concrete, especially when I know there's a low carbon concrete fix that's going to be for sure coming to market. And again, really good progress. It's already being made on that front. So it's a really good question and it's a really important question. But the answer should be you got to do full cost accounting and look at all the landfills that are just being contaminated with so much waste from homes that are not able to withstand the disaster risks that these other concrete materials could. It's again tens and tens and tens of thousands of homes every year, it looks like, equivalent going into with all their toxic materials inside that have burned. So yeah, I think it's really good to challenge the industry to manage that. That's a great question. I'm glad it came up. I'm telling you, we have an answer around the corner. So so it's a really good question.
Question came in from Gabrielle. Curious to hear your thoughts on comparing precast concrete, SIPs, and light gauge steel prefab.
They're all options that work. They depend on climate. They depend on They depend on prevailing disaster risks. They depend on builder preferences. You know, the big advantage of wood, which is not trivial, is how workable it is. Builders love it because it's such a workable product, and you give that up when you go to some of these other systems like concrete. Uh, and so uh, I don't believe in telling a builder you should do this or you have to do anything. I just believe in providing really good um, um, tools and framework for making the most informed decisions. And in the end, if it still makes most business sense to do it with a traditional frame house, that's the way you do it. But I think if you watch the market and see which companies and which builders start to lead the pack, I think they will be the ones innovating from the 150-year-old technology that we're currently using.
You know, the previous question asked about precast concrete. Thomas wanted to ask about a product that I know you like a lot, Sam, and that's Superior Walls.
It's great.
Uh, Superior Walls allows for the integration of utilities within the wall cavities. Can you talk a little bit about the benefit of that there?
Yeah, for people who don't know, and that's great the question came up because I think Superior Wall actually made it. I sometimes wonder why Onyx doesn't use a Superior Wall configuration from the one they currently use, but I guess they've done such great engineering. I just defer. But a Superior Wall is basically not a sandwich. It's a single pour of concrete in a rib configuration. So what it means is when you use Superior Wall uh, concrete panels for a foundation, um, it has 70% less concrete than a normal concrete foundation, stem wall, and footing. And the reason is because the rib configuration is much more efficient using concrete where you need it, not just 12 inches or 10 inches thick concrete stem wall from sill to footing. And so the Superior Wall is amazing. You get rid of 70% of the concrete and you get rid of the stem, the footing because it's like a big bond beam just sitting on the gravel. You don't need a footing. And what that also means is your moisture under the slab has a direct path to drain to the drain tile, not blocked by a footing. And sometimes the details you have to install a cost to maybe provide a path. So Superior Wall is amazing for foundations. Plus, it's 5,000 psi poured in a plant versus 3,000 psi poured in the field for concrete foundations, which means it's more waterproof or it's more water protected because it's just denser. And it's more dimensionally accurate and it's insulated R10 around the entire inside configuration, inside the cavity, around the ribs, all the way around the entire panel. You have R10 insulation. So you have a foundation wall that's insulated and the cavity for more insulation if you want it. Plus it's pre-drilled for wiring and plumbing in the ribs. So it's an amazing product. And for above grade, you can just use the same panel and have all the benefits I talked about with Onyx with the Superior Wall, where it has impact resistance, it has pest resistance and termites in particular. It has water resistance, flood resistance. You can do all these things with the Superior Wall above grade. And so another really good option. And I was going to talk about that, but I cut my slides down to make sure I didn't run too long. So I'm glad the question came up. It's a really good question.
We had a question from Chet in regards to the that worker housing project. Is it possible to build it instead of on a slab, but to build it with SIP flooring on piers?
Yes, you could. SIPs is such a high value thermal barrier. And if I'm doing a crawl space, I'm just going to do an unvented crawl space. And if I'm using concrete for my stem walls, I'm just going to insulate them on the inside. I'm going to put the poly down or a rat slab over the poly as well. Make sure to condition the crawl space directly with the heating cooling system, and you have a great solution. But SIPs are pretty expensive to have the entire floor SIPs versus just the stem walls. And that gives me a conditioned space to run ducts, to run plumbing, have storage below in the crawl space. So you could do what he's suggesting, but I think I would just do it on, I would do a unvented crawl space is what I would do at much lower cost. And I think equal performance.
All right. We had a question come in from Joe in regards to, the perfect wall. Are those feasible in northern climates where you have basements?
Well, I think you're more likely in the northern climate to maybe use something like SIPs versus, let's say, that concrete system I showed you. But anywhere across from Florida to the Gulf states to Louisiana and Texas, and then across to New Mexico and Arizona and California, I'm going, boy, that's where maybe 70% of the housing is being built. And that's where, boy, you need resilience. I mean, you need something that's going to withstand hurricanes, floods, fires. I mean, and termites and all these. I just go, you need to give it a look. You need to give it a look. But up north where it's really cold, I'm going, I need the most thermal performance I can get per thickness. And that's going to be probably more like a SIP for me than a concrete assembly.
All right. We talked about a lot of different wall systems, but Jacob wanted to know, I didn't see any information about a CFS panel system. He's seen more of them in his area, and he's curious where you would rank them from all the options that we've been talking about.
Wow, finally got something that stumped me. I don't know what CFS is. Do you know?
Well, I looked it up just to make sure that I could explain it in case you didn't know. Concealed fastener striated panels. This is a lock joint type system.
Yeah. But the key thing is what I want to know is basically is what is its disaster risk profile, what is its workforce risk profile, and what's its building science risk profile. And I'd have to see the assembly and how it's constructed in the field and so forth. But there's a lot of different
Hold on, Sam. I misspoke. It's cold form steel. My bad.
cold form steel.
Yeah.
Yeah.
My fault, Jacob.
Yeah,
Sorry.
cold form steel, and he's probably talking about steel channel panels.
Yeah.
And yeah, and that's where, so that's basically just continuous insulation on steel framing instead of wood framing is what I'm going to guess it is. And so that's fine, but you have to have no thermal bridging and all those details managed. And if you can do that, you're fine. And steel is recyclable and it's termite resistant and water resistant. So that's, again, there's lots of options for how you can do this. I don't want to make it like these are the only solutions. These are the ones I'm most familiar with. So, but yeah, but a frame panel could be steel or wood. So doesn't it? Could be either one.
Yeah. No, he tripped us up on the acronym, but once we got that cleared up, we're good to go. So final question here, Sam, came in from John. He wanted to know if you or I know of any company like Superior that might be doing prefab multifamily units that can be stacked for mid-rise or high-rise construction.
Mostly in stacked units, I see people opting for modular. That's where modular has there's all these tools out there that have different strengths and weaknesses and risk profiles, but modular is pretty exciting for multifamily. It's just you just drop it in. Although my good friend Aaron Smith, he did a multifamily with SIPs that came out really well. Prairie Crossing, I believe was the name of the project in southwest Minnesota. But it's again, you just have to do the math. You have to run all the considerations. You have to come up with a preference so that you go into the design process and optimize the product for the systems that you're choosing, including the enclosure. But you're going to find nine times out of 10, you're going to find most people in the multifamily space are looking for modular. Has so many advantages.
Yeah. I was trying to rack my brain a little bit because I started my career in the concrete industry. And so I knew of a couple of precast manufacturers who were doing precast single family homes. One company was called Royal. I can't remember if they were Royal Concrete Products or Royal Building Products, but they were out of Florida, and they were doing precast concrete homes that you would be able to drive down the road or put on a train. And it included putting even like cabinetry inside and windows and doors and kind of a modular manufacturer type situation. Well, I don't know if they're still around or not. And then the other one was a company out of Chicago area, Naperville, called Duquesne Precast. And they were doing single family homes as well, but they'd actually gotten their start with if you've ever driven into Chicago, especially from the south part of the city, you just see warehouse after warehouse after warehouse. That was them largely. And so they had all this experience building precast walls for warehouses. They decided to get into the housing industry, and they had an automated system in their plant where it would just, you put in the CAD drawing and the thing just rolled around the plant and poured the walls, and it was very precise. I don't recall whether they got into what I would consider to be mid-rise or high-rise. They might have gotten into like 3-story, like 3 flats, like you might see in Chicago, but that might have been about as tall as they would have gotten. So those are my
You
two.
got more than I got, but Audible, based in Idaho, is doing wood framed panels for multifamily, targeting a lot of California markets mostly as their uh, how they're doing their business. And they're completely robotic. Well, they're robotic, and they have an advanced assembly section around the robotics. So they're real advanced. I mean, everyone's making different investments, and this is what it's scary business. You want to bet on the horse that's going to come through at the end. And so I always admire people that try new innovations and take on so much risk. But I know the basics, which are you gotta have the product designed from the start to optimize a certain system. You gotta pick a system based on all of its true cost factors and related factors and things that keep you up at night. And there are a lot of good, reliable systems out there. So the key thing to do is to, like I said, do the math and compare the systems. But we got to start building faster, better, cheaper. So that's kind of, I think, a good way to wrap up today.
Yeah. Yep, that concludes today's webinar. I really want to thank everyone for attending and asking all the wonderful questions that we got to, because we do really get to every question that we can. Also, thank you to Panasonic Healthy Indoor Living Solutions for their generous sponsorship. We're very appreciative of them. Now, the next Housing 2.0 webinar is going to take place 6 weeks from today. That's June 26th. Our topic is going to be managing high performance certification uncertainty, and that will start at the same time as we did today, which is 2 p.m. Eastern time. So until next time, stay safe, stay healthy, take care, everyone. Have a great Memorial Day, and we'll see you all in June. Take care.